All right, in this video, we are going to talk about probability histograms. All right, so in the previous video, we talked about probability distributions. So here we would start with a probability distribution, and then the probability histogram is basically going to be a graph of the probability distribution. So it's going to display the possible values of the discrete random variable on the horizontal axis down here, 0, 1, 2, 3, 4. And then the probability of each value is going to be represented by a vertical bar here, right? So the probability of 0 would be 0.2. The probability of a 1 would be whatever that is. I think maybe it's 0.45. The probability of 2 is 0.275, it looks like. And the probability of a 3, right, would be 0.75. Probability of a 4 would be that would be 0.075, and the probability of a 4 would be 0.025 here. So, so this histogram is actually the probability histogram for this distribution that we talked about here. Okay, so 0.2, 0.45. Let's just take a picture of that. And then go back to the histogram, and then we can see it. All right. So the probability of 0 was 0.2. The probability of 1 was 0.425. Probability of 2 was 0.275. Probability of a 3 was 0.075. And the probability of a 4 was 0.025. So we can see it's just basically a graph of this probability distribution. Okay. Here's another example, and let's see. This one is actually the probability histogram for that formula that I showed you before. If I it's the probability distribution for this formula right here. Let's see. There we go. And it's hard to tell because we haven't talked about how to deal with this formula yet. But you can see it has these values 0, 1 through 8, and then you would, to get the probability, you would plug one of these numbers in for x, and we'll talk about that later, how that works. Okay, so that's a probability histogram. It's just a graph, right, of a probability distribution, right? And the values are down here, and then the heights of the bars give you the probability of that you would get that particular value. Okay. For a discrete random variable, right, if I add up all of the probabilities, they add up to get 1. And so that's an important fact to know. Okay. So the sum of the probabilities will come out to be 1. All right, a way to interpret probability distributions is this. So if I repeat, right, that experiment and I look at the value of the random variable, okay, that follows that probability distribution, right, the proportion of times each possible value occurs will approximate the probability distribution. So by proportion of times, what I mean is, right, say you did the experiment. Let's pick a particular one right here. So let's say this one here, because this is the one that we'll look at in a minute. So say you repeated this experiment, say 1,000 times, okay? And then over those 1,000 times, you counted up how many times you got a 0, right? For that, for the value of the random variable. If you took the number of times you got a 0 divided by the total number of times divided by 1,000, right, then that should come out to be around 0.2. Now the thing is, it might not be exactly 0.2, right, when you do that. It might be a little bit more, it might be a little bit less, okay, because, right, this is based on chance. We can't say for certain, right, what value we're going to get. So sometimes maybe you got really unlucky and got a bunch of zeros in a row or something like that. But the thing is with these, as it says here, right, the more that you do these experiments, right, the more that you repeat it, that proportion, right, the number of times you get a value divided by the total number of times that you have repeated, will get closer and closer, right, to the probability distribution of X. Okay. So that proportion histogram, if you drew that out, that will approximate the probability histogram. Okay. All right, so what I want to do next is just illustrate that fact to you through some simulations, okay? And so we're going to do exactly this. We are going to define a random variable, and then we're going to run through some repetitions, right, of that random variable. And I'm going to do that with a couple of things. First off is the programming language R. This is for statistics. That's its number one focus. And so if you are going to be in an area where you're going to use a lot of statistics, like biology or psychology or even anything like that, and you think you are going to be heavily involved in the statistics part of that, then learning R is a pretty good thing to do. The other thing I'm going to be using is something called RStudio, okay? And RStudio is basically a tool that you can use to program in R. It kind of is a collection of a bunch of tools together that helps you do that. All right, so RStudio kind of looks like this, okay? And up here, this code is written in R, and so you can kind of see the results of that. In this, and so your code is up here. This is our code up here. This is the output window, and this is a viewer window. I'm gonna switch this off right now because right now it doesn't really have anything to do with the first simulation that we're gonna run. And this is just a variable window up here. So all you really need to focus on is when I run this down here. So what I've got is, if I go back and look at this, I've got this distribution here, this first one. And so I've written that up here in RStudio. You can see I have the values right here, 0, 1, 2, 3, 4, and here are the probabilities, right, that are listed in that table. 0.2. Probability of 1 is 0.425, just like I have here. Probability of 2 is 0.275, and so on and so forth, okay? Okay, so what I'm going to do is I am going to repeat this experiment. So let's just pick a specific experiment. And let's say it follows this distribution, okay? So what I'm going to do is, in this experiment, is I go out and ask 4 people, right, whether they prefer crunchy peanut butter over smooth peanut butter. And this, the outcome that I get is how many people said yes, okay? How many people prefer crunchy. All right, so here I'm going to run this experiment 100 times, and it's going to show me the values that I get when I do that. So here, right, I went out and asked 100 people. 22 people said, I performed this experiment 100 times. Okay, so I went out and asked 4 people. 22 times when I did this, 0 people said yes, they prefer crunchy. 34 times, right, when I repeated this experiment, 1 person said, right, that they prefer crunchy. And 33 times out of the 100, 2 people said they prefer crunchy. 6 times out of the 100, 3 people said yes, they prefer crunchy, right? And then 5 times out of the 100, 3 people said yes, right? Or 4 people said yes, they prefer crunchy. All right, so here's my probabilities over here. 0.22, 0.34, 0.33, 0.06, 0.05. So again, these numbers aren't exactly the probabilities that we have, right? 0.22, I got it when I did 100 times. That's my the proportion distribution, right? 22% of the times. The probability was 0.2. For 1, it was 0.425, and you can see the proportion value was 0.34. Okay. For 2, it was 0.33. When in the probability, it was 0.275, 0.6 up here, 0.05, and 0.025. So you can see the values aren't not exactly the same. But the point of what we're talking about is if we repeat this, and so now I'm not going to do it just for 100 people or 1,000 people. I'm going to go out and 10,000 times I'm going to go ask 4 random people, right, whether they prefer crunchy or smooth, if they prefer crunchy over smooth peanut butter. So if I run this, right, you can see that the numbers that I'm getting are pretty darn close. 0.2017 is very close to 0.2. 0.04267 is pretty close to 0.425. 0.2753, 0.275. 0.0726, you can see those are pretty close. Again, they're not exact, but the point is, the more I do this experiment over and over again, the more this proportion distribution, right, that is the number of times 0 people said that they prefer crunchy, right, is going to get closer and closer to these numbers here, okay, to the probabilities. All right, so that's simulation 1. In simulation 2, I do the same thing, okay, except this time what I'm going to do is draw the histogram out. So I'm going to run this. And here is the histogram that we have for this distribution. So it's kind of in a light purple, I don't know, lavender color here. So that's this distribution right here. So this is the probability histogram, right, for this random variable, the same one that we were talking about in the previous simulation, this one right here. Okay, so those are the probabilities. So now what I'm going to do is I am going to go repeat this experiment 10 times, okay? And then in the light red color, that is the proportion histogram. All right, and so you can see it looks different here, right? It looks a lot different than the probability one, because I only did it 10 times. So basically what happened in this one, right, was you can look at the data up here. Of those 10 times, right, 4 out of those 10 times I repeated that experiment, I got 0 people said yes. I mean, 4 people said yes, right? About 2 times out of that 10 times, right, I had 1 person say yes, they prefer crunchy over smooth. All right, so if you do 4 out of 10, that's 0.4 right here. And then if you do 2 out of 10, that's 0.2. And then 2 times I had 2 people, so that's this bar right here. 2 times out of the 10, I had 3 people say yes, and so that would be another bar here, 0.2. Then I had nobody say that I did 4. No times out of the 10 did I have 4 people that said yes. Okay, so here I have no red bar. Right? So the red bar is the proportion or observed, right? Proportion, and then these bars, the lavender bars, are the probability. So 10, I'm going to go ask 90 more people, or 90 more groups of 4 people. All right, and so here you can see, right, the bars, the red bars are a little bit closer, right, than the purple bars, okay, are closer to the purple bars here. All right, so you can see that the histogram, right, the red histogram for the proportion is looking more and more like the one for the probability distribution. So again, I'm going to repeat this experiment now 1,000 more times. Okay, so I'm going to go out and ask groups of 4 people another 1,000 of those, 1,000 more groups of 4 people. Right, I'm going to ask each person in the group, do you prefer crunchy over smooth peanut butter? And write down how many people said yes. Okay, and that's going to change everything. And now you can see that the red bar and the purple bars are, it almost looks like one now. There's slight differences you can see here, right? So you can see a slight difference in this bar, right? The other differences, there's some differences here and here, but it's very, very small. Okay, so what that means is that more and more, the more I'm repeating this experiment, right? Number one, the closer and closer the observed values are getting to these probabilities up here, right? The probability in the probabilities in the probability distributions. In the histograms, right? That red histogram of the observed, right, proportion of times I got that value is getting closer and closer to the probability distribution. So let's go do it 2,000 more times. All right, and you can see very, very close still. All right, so that's what we're getting at here in this slide, is that if you make a large number of independent observations of a random variable, the proportion, right, that is the number of times the value occurred divided by the total number of times you repeated, right, the experiment, those values will approximate the probability distribution. Okay. All right. So on these homework problems, you don't have to sketch out the probability histogram. We didn't really talk about that, and I don't expect you to use RStudio to do it. I'm just mentioning that in case anybody's interested in there. So on those problems that are assigned from the homework, you do not have to sketch, right, the probability histogram. It's not that many people sketch these by hand these days anymore. They use some kind of technology to do it. So, all right, so that's it for this video.